this second chapter of trigonometry, we were going to be extending our knowledge of the trig functions. In this lesson, we will be looking at the transformations of sinusoidal functions.
So one of the things you're going to notice right away with this lesson here is that we're doing the same old with our functions here, but we're going to call it something different here, okay? So, and case in point right here, vertical displacement is the vertical translation, okay? But we call it vertical displacement mostly because of the applications that trig functions are used in, okay? So this comes more out of where it's used as opposed to like a strictly math origin here, or else we would have just left it as vertical translation. And that's what we're going to do. We're just going to add a D. Okay, we're going to let D refer to the vertical translation for those graphs right there. Now, what happens here, before we even get to this, think back to what our sine and cosine graphs look like. Okay, in fact, you know what I'm going to do? I'm going to grab those right now because I want to make sure that this is really, really clear. Okay, so here's our sine and cosine graphs. Now, remember the I'll focus right into the sine graph. Remember our four motions here, okay? Sine starts at the midway. Now, in this point, at this case right here, that's on the x-axis, but it starts right on its kind of midway point, vertically. It goes up to the maximum, down to the middle, down to a minimum, up to the middle here. Okay, so this is what a sine graph looks like. Now, the graph, though, can be translated up and down, and if that happens, this middle line moves with it, okay, and we call that the median of the graph here. And now we'll go back to this lesson right here. Okay, that's going to be the midline or the median of our graph here, and it's essentially going to be D, okay, because in the original trig functions here, if it hasn't been transformed, that is along the x-axis. That's where y is equal to 0, and so if I translate that up or down by D units, then the new line is going to be y equals D. Okay, so on the original, okay, think of it like this, on the original, okay, the median is y equals 0, but then it translates up or down by D units. And so now the equation is going to be, therefore we're going to get y equals D. That will be the middle here. Okay, so and if you like here, it's the D is going to be the line halfway between the maximum and minimum values, okay? And we're going to see that in just a second here. And it's the line that cuts your graph into two equal parts, okay? So now if D is positive, the thing moves up. If D is negative, it moves down. That's totally consistent with transformations here. And here's another little formula that you should know. D is the maximum plus the minimum divided by 2. Now think about that a little bit. All that we've done there is an average. Okay, it's just the average of the max and the min values. Okay, it runs right down the center here. And now you can use that value in a couple of different applications. Sorry, I probably said that the wrong way here. These are the formulas that you typically will use when we're doing applications, when you're doing word problems here. If you want to figure out the maximum value of a function, it's the amplitude, okay, plus the median line, the middle line here. If you want the minimum value, it's going to be basically the median, the middle line here, minus the amplitude. Now remember in this case that the amplitude is always positive. Okay, even if there's a negative in front, that negative in front just tells you the type of graph you're looking at. Okay, it's not the amplitude. Okay, so like a -2 in front, the 2 is the amplitude, the negative is referring to the type of graph you're looking at. Now with those little bits in mind here, let's just take a look at what we've got here. Okay, and this is a really standard kind of question. In fact, this is a great question because lots of stuff has kind of changed here. So first of all, notice that the maximum value that this thing gets to is 1, and the minimum value it gets to is -3. So here's our max, here's our min. Okay, now our median or our middle value here is going to be our max plus our min divided by 2. So this is going to be 1 plus -3 over 2. Let's just think about that. 1 plus -3 is -2. Divided by 2 is -1. So our D value here is, our D value there, oops, don't want to break this again, is going to be -1. Now after I find that, typically what I would encourage you to do is come to your graph here, go to -1, and just darken that line. That is the middle of this curve right here. Okay? That's useful in a lot of different ways here, and you'll see this in a little bit. The amplitude, well, the amplitude, that is our max minus our min over 2, and so it's going to be 1 minus negative 3 over 2. Okay, whoops, sorry, you can't see that. 1 minus negative 3 will be 4, divided by 2 is 2. Now let's just look at the graph here, 2. What the amplitude is supposed to be is the distance from the middle to the maximum, or the distance from the middle to the minimum here. And yeah, that's 2. Down 2, up 2. Good. It's exactly what I thought it should be here. Our period, well, I can read the period off here. Remember that a period consists of those 4 actions here. And once I've identified that middle line, this actually becomes really easy. Notice I'm at a maximum right here. So my first action is going to be to go to the middle, go to the minimum, up to the middle, up to the maximum. There's a period. And I can see right now that it goes from 0 to 2 pi. So there's our period, 2 pi. As a result, let's think back to our formula there. I know that b is going to be 2 pi divided by the period. And so in this case, it'll be 2 pi divided by 2 pi. Well, that's just 1. Okay, well, the b value is 1. And my range. Okay, well, I can read that off here. But I can also use my formula. Okay, and in fact, I'm going to use the formula first, then I'm going to compare it here. I know that my maximum is going to be my d value plus my amplitude. So my d value was negative 1, and my amplitude was 2. So my maximum value is going to be positive 1. My minimum is going to be the d value minus the amplitude. In this case, d value is negative 1, the amplitude was 2, so it's going to be negative 3. So the minimum was negative 3, and I can verify that visually. My maximum was 1, I can verify that visually. And so my range is going to be all the values between negative 3 and 1. So everything here works really, really well together, okay? You need to know those formulas, though. They won't show up on the formula sheet, but man, are they ever useful. Additionally, again, word of advice, once you've established what the median is, what that d value is, okay, I suggest you just draw a nice dark line along that value there, because that will identify the middle of the graph. That will help not only with determining the period of the graph, which it did in this case, but you'll see in a little bit here, it's going to also help us find out determine the horizontal translation.
The characteristics of sine theta plus d and the cosine of theta plus d.
Okay, now before we start looking at some specific examples here, I just wanted to take a brief moment here just to talk about this again here. And I've done this before, I want to do it with you again here. Remember that sine and cosine are just functions. Okay, they are trigonometric functions of the variable theta here. So what's happening here, this can actually be rewritten as f of theta, if you want to think of it like that. This is y equals f of theta plus d. It's really important that you remember that even though we call this a vertical displacement, okay, if you want this to be consistent with the course that we've been going through thus far, d is just a vertical translation. It's all it is, okay? There's nothing more complicated than that. This just tells you how far up or down you are moving the graph. But to get that correct, you need to know what that is first. So this is going back to the previous lesson here. You need to be very familiar with what sine theta looks like or what cosine theta looks like, and the negatives of both of those, before moving those things vertically will make any sense to you.
Y equals the sine of theta plus 3.
Okay, so in this case right here, I've got the sine of theta plus 3. So I know that this is a vertical transformation or vertical translation 3 up. Okay, or we'll call this a vertical displacement 3 up. Either way, this is 3 up. Now, before we do that, what I'm going to do here is 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. I'm going to draw out for us our trig function here. Now, I got to be a little careful about this because I want this to fit on this grid here. And if I play with the scale too much, it's not going to work. So I'm starting at 0. By 90, sorry, at 30 degrees, I'm at a half. At 90, I'm at 1. Down here, I'm at a half. 180 degrees, I'm at 0. And then it's going to be at a half. Negative 270 will be negative 1, a half, and then 360 is 0. So my graph here, y equals the sine of x, and it's just a little squished here because of the scale. but this right here is y equals the sine of x. Now, when we take and translate this thing 3 up, we are moving all of these points 3 up, okay? That's all we're doing. Now, but it's the y coordinate, okay? In fact, we might even want to think about this in terms of our mapping. This is going to be x comma y is going to become x comma y plus 3. This is moving 3 up. So now, this point here moves up 3, 1, 2, 3. Yeah, there it goes. This half point moves up 3, 1, 2, 3. Okay, this maximum point moves up 3, 1, 2, 3. 1, 2, 3. And then back to 0, 1, 2, 3. Okay, now the points that dipped below the x-axis also go up 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. And then finally 1, 2, 3. And so now I'm just going to connect my dots. And away we go. Now, notice originally that my median line here was at y equals 0, but now that middle line has been moved up 3. Now my middle line is at y is equal to 3. So you can make a direct comparison between the value of the vertical displacement and the value of the median here.
Y equals the cosine of theta minus 2.
All right, so for this one right here, notice that it's been moved 2 down. There's been a vertical translation 2 down, or a vertical displacement, if you will, 2 down. Either way, however you want to look at it, there you go. Now, I'm going to draw the scale out here. Now, I can be a little bit more generous with my scale in this one because we're only moving it down 2. But what I'm going to do, like I did with the previous question, I'm going to draw cosine first. So here's my pi over 2. This is going to be 3 pi over 2. Just helps me out to have that there. So I know that a regular cosine will start at 1, okay? At 60 degrees goes to a half right there, and then 0. And then down here it'll be at a half, and then, whoops, negative 1. Sorry, I drew that a little bit too far. Comes back up, and then at a half there, and then there we go. So draw the graph. Oh, that's not very pretty, but anyway, you get oh boy, you get the idea. Sorry about that. Okay, now this has been a vertical translation 2 units down. So what's going to happen here? Let's take a quick look at our mapping point again, because I want you to realize that this is just a transformation. This is going to be x comma y minus 2. So all of these coordinates here are going to be adjusted 2 down here. So this point right here, the maximum will go down 2. It goes down to here. This point will go down 2. So 1, 2. Okay? On the x-axis here, down 2, 1, 2. This guy down here, 1, 2. The minimum, 1, 2. Now that takes us right to the bottom of the graph here. Here it was going to go down 1, 2. The middle, 1, 2. This point right here, 1, 2. And then our maximum here, 1, 2. And then I connect the dots. Hopefully I make it look a little bit better than the original here. Okay. And there you go. There's what the graph looks like. Notice again that the median here was originally at y equals 0, but now the middle has been moved down 2 units, and so now it's y equals negative 2. But anyway, that's what that graph looks like. It's just been translated 2 units down.
The characteristics of the sine of theta minus c and the cosine of theta minus c.
Okay, now we're going to take a quick look at another transformation here. And again, notice that this is happening within the function. Again, sine and cosine are just functions of theta here. And so there's been a change inside the function. This is like writing y equals f of theta minus c. So what this is this is going to be a horizontal translation, okay? Horizontal translation. Now, we don't call it that. Okay, we call it something different here. Okay, when it's a sinusoidal function, a horizontal translation is actually called a phase shift. And again, the change in vocabulary is simply because of the applications of this type of math, okay? Particularly in physics. It's called a phase shift. Now, it is, though, in its essence, if you want to be consistent with this course here, it's just a horizontal translation. That's all it is, okay? And so, just as it was before, if C is positive, then this thing moves to the right, and if C is negative, it moves to the left. However, notice that the operation that we're dealing with here is negative. Okay, so if you saw, for example, theta minus 3, then c is positive 3. The operation here is subtraction. If you saw theta plus 3, then you would know that c was negative because I would have a minus a negative here. Another way to think about it, and I know that I've talked about this in previous lessons here, is if you really want to get a sense of what that transformation is, just think about what you would do to isolate the theta here. Okay, so for example, if you saw theta minus 3 here, to get the theta by itself, you would have to add 3 to the other side eventually. Well, there's your translation, adding 3. If you saw theta plus 3 here, then the last thing you would do to get theta by itself would be to subtract 3. Well, there we go, 3 to the left, minus 3. That would be your transformation.
Y equals the sine of theta plus pi over 2.
Okay, so now when we take a look at y equals the sine of theta plus pi over 2, notice in this case here that c is going to have to equal negative pi over 2. Now that's one way of looking at it, and so this means a horizontal phase shift, if you will, pi over 2 left. Okay, or just think about it as it's going to be a horizontal translation, pi over 2 units to the left here. Now before we do this though, I'm going to put sine on there. Okay, now here's going to be pi over 2. They've already got the 1 written out here. It's going to be negative pi over 2. 1, 2, 3, this will be 3 pi over 2. So sine is going to start up here at, what is it? That's going to be 30 degrees at 30 degrees. I'm sorry, sine doesn't start up there. That's crazy talk. What's going on with me? Sine's going to start here, my mistake. 1, 2, 3, 4, 5. So 30 degrees is going to be there. 60 is going to be somewhere up here. And there it is. So now we just keep drawing this out. That's going to be down here at negative a half, which would be there, there, there. Just connecting the dots. And actually, I should probably go left a little bit here because the graph gives us that room there. So that'll be down there, there. So here's what sine looks like. Okay, just connecting the dots. So this right here is y equals the sine of theta. And now what I'm going to do is move this pi over 2 units to the left. Now again, I'm just going to take every point and move it to the left here. Now, let's just take a look at what this is going to mean here. Now pi over 2, on my particular grid here, pi over 2 means moving everything over 3 squares. So it's going to move this one to 3, back 3, this one 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 back 3, this guy back 3, and so on. Okay, this is going to go back 3, this is going to go back 3, this will go back 3, 1, 2, and so on until we get 1, 2, down to here. Whoops, yeah, down to there. So here's what the transformed function is going to look like. Now I could probably keep going here because I know that this is going to extend infinitely in both directions. So this is going to come back this way. This will be down to the half there, there. So this is going to drop down like this. Over here, this will go up to the halfway mark, up to here, and then up to there. So right here, this is y equals sine of theta plus pi over 2. Okay, that's what that graph looks like. The whole thing has been moved over, pi over 2 units to the left. And notice, by the way, notice that now it starts on the positive, at its maximum on the y-axis. Very similar to a cosine graph, okay? In fact, if I was just looking at this graph right here, I probably wouldn't jump on to the conclusion that that was a sine graph. I would assume that that was a cosine graph. We're going to talk about that a little bit more in just a bit.
Y equals the cosine of theta minus pi.
All right, well, we're going to do a similar sort of thing with cosine here. This time, notice that my c value is going to be pi. So this suggests a horizontal phase shift, pi to the right, which is just a horizontal translation, pi to the right. Okay, so we'll just understand it like that. Now, first thing I'm going to do here, though, is I'm going to graph out cosine, just your regular cosine. Now, I've got to check my scale here. 1, 2, 3, 4, 5, 6. So this is going to be pi over 2. 1, 2, 3. 3 pi over 2, 1, 2, 3, 5 pi over 2. Now we've given ourselves a lot of room here, but it's because we are translating it by half of a period here. 1, 2, 3, negative pi over 2, and so on. Now cosine starts at its peak, okay, And at 30 degrees, it'll be, well, it'll be here, roughly here. At 60 degrees, add a half and then down, and then add a half, down, minimum, and here you go. We'll just fill out these little dots here. Now there's my 1 period for cosine, but I've been given enough room here. I could have done that better. Hold on. I've been given enough room here to keep going here, so I will keep drawing out the pieces. And we're down there, all the way down to our minimum. Give ourselves a couple of, we're going to give ourselves overall a couple of periods here. Going back, similar sort of thing, down to here, 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 there, there, there. I'll draw this out. Now, so there's my cosine, right? Okay, so here it is. Y equals the cosine of theta. Now what we're going to do is we're going to move all of these points to the right pi units. Now, pi on my graph here is 1, 2, 3, 4, 5, 6. 6 of these little blocks here. So this minimum here, whoops, look like this, is going to go 1, 2, 3, 4, 5, 6. It's going to go right to there. Okay, this is going to go over 6. 1, 2, 3, 4, 5, 6. This is going to go over 6. 1, 2, 3, 4, 5, 6. And this is going to go over 6. 1, 2, 3, 4, 5, 6. Okay, and so now what's going to happen here, it basically, notice that these things have switched. Notice that now my maximum and my minimums have alternated. So now this thing's actually going to, because of the symmetry, it's going to go through that x-axis. It's actually going to look something like this. I mean, a little nicer here, but you get the idea. And it's going to extend backwards the same way. Like my maximum here is going to be right above my minimum, so it's going to drop down like that. And so right here is going to be my y equals the cosine of theta minus pi. Okay, but that's what the sort of thing that you would expect. Oh, this part here looks terrible. Anyway, well, it doesn't. None of it looks great, but anyway. This is the sort of thing that you get when you would translate something by a half of its period. You would expect that the maximums and minimums would simply swap here. Anyway, there you go.
Now we're going to look at the process of combining transformations.
All right, well now for a couple of moments here, we're going to talk about the trig functions in the same way that we talked about functions in general in the transformations chapter. We're going to talk about what it means to combine transformations together. Now, look at our general functions here. A sine of b, parentheses. Oh my goodness, note those parentheses. X minus c, close brackets here, plus d. And then the same thing with cosine. There's going to be some very, very similar issues here. One of them is, remember that the horizontal stretch always needs to be factored out of the translation in order to see clearly what's going on, okay? So remember, always remember here, factor the stretch. Okay, factor the stretch out of the translation. Now, hopefully you remember what I'm talking about here. It will come up here shortly as an example, but hopefully you remember what I'm talking about. The amplitude is going to be the leading coefficient here, okay, in front of the function, and the amplitude is going to be the absolute value of a, or if you want to think of it this way, the maximum value minus the minimum value divided by 2. We don't use the negative sign if one exists there. We don't include the negative when we're talking about the amplitude. That's not what it is. The b value is essentially our frequency. Okay, remember b is frequency, which means it's going to be the number of periods, okay, from 0 to 2 pi. But because of that, it allows us more directly to find the period, and that's really what we're interested in. So you take your 2 pi, you're going to divide it by b, or 360, you can divide it by b, okay? And again, I'm not concerned if b is negative, because that's going to just introduce a reflection in the graph. I'm not really all that concerned, I just want the value there. Our C value is a horizontal phase shift. Now, this is the one that requires the most work. This is the one that can be the most confusing. And as we go through the examples here in a little bit, you're going to see that. Okay, you're going to see how this one requires essentially the most thought, the most deliberate action to get that to work out properly. D is the median. Okay, it's the vertical displacement. Okay, it's the if you want to think of it, it's the vertical middle of the graph here, and we can find that using max plus min divided by 2. And then once you've got the D value, the median, and the amplitude, you can figure out, if you didn't know this already, what the maximum and minimum values of a function are just by using this equation right here. Remembering that A, again, is the amplitude, and amplitude is positive by definition, okay? Even if there's a negative in front, that negative is simply telling you that it's a negative sine graph or a negative cos graph. It's implying a reflection. It's not included with the amplitude.
Complete the following table.
Okay, so now we're gonna fill in this chart here, identifying all these pieces from these equations right here. Now, for simplicity's sake here, I think what we'll do is let's just focus on one property at a time here and get that down pat. So amplitude is associated with the vertical stretch. The vertical stretch is going to be the coefficient in front of the function. So in this case right here, the coefficient in front of the sine is 1. Amplitude is 1. Here, the coefficient in front of the cosine is 2. The amplitude is therefore 2. That's the vertical stretch. Now the coefficient here is -3, but as I've been trying to say over and over again, not negative. This is going to be +3. Okay, I'm only interested, when I ask you about the amplitude, I'm only interested in the stretch, not the direction that this thing's moving. And then down here, again, there's a negative sign in front. I'm not concerned about that. I'm concerned about the value, and in this case, if it's not written, the value is 1. So the amplitudes here are going to be 1, 2, 3, and 1, respectively. Period. Period is going to be related to the frequency, okay? So we're going to take that B value, and I think in this case here, for this one, now this one right here, you don't know whether this is in degrees or radians, but I can clearly see that these two are in radians. Let's make this one here in degrees then, just so that there's 2 of each. So my period here is going to be 2 pi divided by the B value. Well, the B value here is 1, okay, because it's the coefficient of the x here, the number in front of the x, and in this case it's 1, so the period here is going to be 2 pi. Here, the B value is clearly going to be that 2, so period is going to be 360 divided by 2. So 360 divided by 2 is going to be 180 degrees. There's my period. In this case here, the B value is 1/2. Okay, and so my period is going to be 360 divided by 1/2. Well, divided by half means multiplied by the reciprocal. That's going to be 720 degrees. And here, the coefficient of the x is 2, so the B value here is 2. And so 2 pi, because this is in radians here, I can see that from that value right there. 2 pi divided by 2 is just going to be pi. So there we go, 2 pi, 180 degrees, 720 degrees, and pi respectively. Horizontal phase shift. Now this is the horizontal translation, the C value here. Okay, I can see right now that what I'm subtracting inside the function is pi over 4, so this is going to be pi over 4. Now the question is what direction? Well, if I tried to get x by itself, I'd have to add pi over 4. So adding implies to the right here. So this is going to be pi over 4 to the right. Here, well, notice that there is nothing that I'm adding or subtracting to the x here. Now, don't say +5. Please don't do that. That 5 is outside. Order of operations would dictate that +5 happens after I evaluate the cosine. That is not being added to the x. That is being added to 2 times the cosine of 2x. Okay, that doesn't happen until quite a bit after we deal with that. So there is nothing here. There's no horizontal phase shift. Inside here, look at what I'm doing with the x. I am adding 30 degrees to it. That's even before I multiply by 1/2. So that means this is going to be 30 degrees. Now I got to figure out whether it's left or right here. And I ask, well, what would I do to get x by itself? Well, the last thing I would do here would be to subtract 30 degrees. Subtract 30, that's 30 degrees to the left. Now this last one here, don't get thrown off by it. This one was asked like this on purpose. Notice that there's no parentheses here separating the 2 and the x. That means that the horizontal stretch has been distributed through that binomial that identifies the translation here. So I have to factor that out first before I can clearly identify what the translation is. And this bit here becomes 2 x minus, now if you take the 2 out of that 2 pi over 3, you're just going to get pi over 3. So there's my b value, and it's quite clear. Nothing's changed in that regard. I don't have to go back and alter anything. That's correct. But the c value is now pi over 3. Okay, and now if I want to figure out what direction it is, I just ask, well, what would I have to do to get that by itself, the x? And I would have to add pi over 3, which means pi over 3 to the right. Awesome. Now, the vertical displacement, this is now a fair bit easier than what we just did because this refers to the value that I'm adding at the very end. Here, notice that there is no value at the very end here, so there's been no vertical displacement. Here, I'm adding 5 to that function, which means this is 5 up. Here, at the very end of the function here, now it's a little squished in there, but it's minus 2, which means I've gone 2 down. And on this last one right here, okay, I'm adding 2 at the end, so this is going to be 2 up, just exactly what I'm seeing. Okay, now, last but not least, identifying the range, okay, which is important for many word problems that we do. And remember, range is going to be d minus the amplitude out to d plus the amplitude. Okay. Well, the vertical displacement was 0. There was no vertical displacement, so this was like 0. So this is really just the negative amplitude to the positive amplitude. Actually, you know, nothing happened to this thing vertically anyway. All that happened was it was moved horizontally a little bit. So the range stays the same, just exactly what I would expect of a sine graph, -1 to 1. This one's a little different though. Our median value here, our middle is 5, and our amplitude is 2. That means from the middle, at a y-coordinate of 5, this thing dips down 2. So from 5 down 2, this is going to be 3. And then from 5, I go up 2. Okay, 5 up 2 is going to be 7. So this is going to fluctuate here between 3 and 7. Okay. This next one. The d value here is -2. Okay, so that's where the middle of the graph is. My amplitude is, now don't get thrown off by that. It's not 3, the amplitude, sorry, not -3, the amplitude is +3. So starting at -2, I'm going to go down 3. Well, -2 minus 3, that low value here is going to be -5. And then -2, there's my middle again, -2, and then I go up 3 from it, because that's how my amplitude works. It's the separation here. It's amplitude goes down, amplitude goes up. So up 3 from that is going to be +1. So this graph here is going to fluctuate between -5 and 1. And now finally here, my d value here is at +2, and my amplitude in this case, again, don't get thrown off by the negative, it was just a +1. So at the middle is 2. If I drop down 1 from that, that's actually going to take me to 1. And starting at 2, if you go up 1, okay, you're going to go up to 3. So this graph here is going to fluctuate between 1 and 3. And there's all those bits of information that this table was looking for.
Write the equation of the sine graph given the following.
Okay, this is a good question. We got a lot going on here. So we're going to write the equation. Okay, like I said before, write the equation of the sine of the graph, and we're given 2 different options here, either a positive sine graph or a negative sine graph. What we're saying here is that, look, there's multiple different ways I could write an equation to get the same graph here. And I'll show you how you interpret that in just a second here now, and hopefully that makes a lot of sense to you. The first thing we got to do is get the pieces of it. Now, to get the amplitude and the vertical displacement, I need the maximum and the minimum values here. So I'm just going to read this off here. My maximum is going to be 4, and my minimum here is -4. Now that's enough to figure out what my amplitude is. Okay, in fact, maybe what I'll do here is I'll zoom in a bit here. My amplitude becomes the max minus the min over 2. So that's going to be 4 minus -4 over 2. Well, 4 minus -4 is 8, divided by 2 is 4. The amplitude is 4. My vertical displacement, d, is going to be the max plus the min over 2. And so 4 plus -4 is just 0 over 2, well, just 0. So in other words, there's been no vertical transformation here. Okay, this graph has, if it's been translated at all or transformed at all, it has not been moved vertically. Now I'm going to find the period here. And when you're looking at a graph like this, finding the period for some people is actually very difficult. So this is what I suggest you do here. Let's approach this. We're going to kind of approach the graph twice. So first of all, what I'm going to do is I'm going to pick a peak and a peak, or a trough and a trough here. Now the easiest thing for me to do right now is to pick the minimum value here and the minimum value here. Okay, now instead of trying to figure out what the period is, I'm just going to count. I'm going to turn this into a counting problem. So how many blocks, how many little marks on the grid is encompassed by this period here? That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 blocks. My period is going to be 12 blocks. Okay? I just counted it out. Now, starting on my origin, I'm going to count out 12 blocks and see what I get. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 12 blocks, that's 2 pi. So my period here is 2 pi. Okay, so there hasn't been a horizontal stretch here. So in other words, my b value, so my period here was 2 pi, which means my b value is going to be 2 pi over the period, which will be 2 pi, or just 1. So nothing happened there. Okay, this is the tough one, horizontal phase shift. And here we go. We know that the middle of the graph is the x-axis right now. That didn't change because there was no vertical displacement here. Okay, let me show you how this works here. We are looking to find a sine graph. Okay, a positive sine graph and a negative sine graph. Okay, now if you think about sine and cosine, okay, and look at those graphs, the beginning graphs from the previous lesson here. A cosine started here, a sine started the middle, cosine started there, sine started the middle, cosine, sine, cosine, sine. Sine always starts along the middle. A positive sine starts by moving up. Its first motion is a positive motion here. So the middle here is a good starting point for sine, but because this one goes down, this is actually a good starting point for negative sine. Okay, so not this one, for positive sine. Here's a very good starting point for positive sine because it starts in the center and moves up. Now, this should have been right on the origin, but it isn't. How has it been moved? Well, it's been moved 2 blocks over to the right. Okay, that should have been right here. Sine would have started here. It's been shifted over. All I want to know is by how much. How far over did that go? Well, 2 blocks. Now, I don't know how much a block is. Let's count that out here. Here's pi. So 1, 2, 3, 4, 5, 6. Okay, well, there are 6 blocks to get out to pi. That means each block is pi divided by 6. 2 of them would be 2 pi over 6's. Oh, pi over 3. This is going to be pi over 3. So if this is my sine graph, if I'm going to do a positive sine graph, the equation would look like this. Y equals positive amplitude, so positive 4, because I want my a value to be positive. Sine of, the b value is just 1, so don't worry about it. My translation, though, is going to be pi over 3 to the right, so minus pi over 3. And then my vertical displacement was 0, so I don't even need to write that in there. So there's my equation right there. So my horizontal phase shift, if a is greater than 0, was 2 pi over 3 to the right. But what if we're talking about a negative sine graph? Well, we just pointed out here that this would be a good spot for a negative sine graph. Okay, because it starts at the center and its first motion is to go down to the minimum. That's what a negative sine graph does. So this is 1, 2, 3, 4 blocks to the left. That's 4 pi over 6's to the left. Well, that's 2 pi over 3. So negative 2 pi over 3. There it is right there. Negative 2 pi over 3. So my equation will be y equals, now in this case I want my amplitude to be negative, so it's negative 4 sine of, now the b value is 1. Okay, b value is 1, so I don't have to put anything in there. X. Now this time, the graph, the negative sine graph, that should have been on the origin, but it has been pulled over here. It's been pulled over 2 pi over 3 to the left. So to communicate that, I do x plus 2 pi over 3. And so there you go. Those two equations right there, if you graph those two, you would get exactly the same graph that we're looking at right now. And I should have mentioned here that if a was less than 0, then this became 2 pi over 3 to the left. Oh, and my mistake. It wasn't 2 pi over 3 to the right. It was just pi over 3. Sorry. Messed that up. It's right over here. It's right in the equation. It's just wrong when I wrote it in there. And there you go.
Write the equation of the cosine graph given the information in the previous question.
Now for this question right here, we're still referring to this graph up here. And so most of the details are the same. The amplitude is the same, the period is the same, the vertical displacement is the same. So I can almost jump right into this and say this. Well, look, if I want a to be positive and this is a cosine graph, this has got to be 4 cosine, the b value is 1, so this just becomes x. Okay, well, I don't know what the horizontal phase shift would be, but I do know that the vertical displacement was 0, so that's it. Likewise over here, if I want my a to be negative, this would be y equals negative 4 cosine of, the b value is 1, so x, but I don't know what the phase shift is supposed to be. So let's talk about the positive one first here. We'll just go up here. Remember what a positive graph looks like, a positive cosine graph. It starts at its peak and drops down. Well, that could be here. That could be here. There's two possibilities. But I'm lazy. So we're going to pick the one that's closest to the y-axis because that's going to give us the smallest phase shift. Okay, and that's the only reason I do that, just because the number's smaller. And in this case, it looks like this one is closer because it's only going to be 1, 2, 3, 4, 5 blocks away from the axis, whereas the other one is going to be negative 7 that way. Each block was pi over 6. So my first positive cosine graph has the beginning point moved to the right 5 pi over 6s. Okay? Now my negative cosine graph starts at the bottom here, and this one is obviously the closest one, and the beautiful thing is it's only one block to the left. I know that a block is pi over 6 because I counted it out. If there are 6 blocks from 0 to pi, each block is a sixth of pi. Okay, just divide pi by 6. So here, this means that the graph was moved to the left, remember x plus pi over 6. And that's those right there. I'll just zoom out a little bit. Those are the two equations that we're looking for here that are cosine functions, but they'll both give you that graph, okay? Both of them.
Write the equation of the cosine graph of the following, given that a is greater than 0.
Okay, I like this question because you can see that there's been a bunch of change to this graph. This is not your basic starting at 0, goes up to 1, down to negative 1 sort of graph here. This is a good one. Now, we're being asked to come up with a cosine graph where the a value is positive. Now, right away, this gets me thinking here, okay, if it's a cosine graph and a is positive, that means that the function, or sorry, the period starts at its maximum. So that could start here, here, or over here. The one that's closest to the y-axis is this one. So this is very likely my start. Okay? If it was a negative cosine, it would be down here, and then sine would start somewhere along the middle here. But this one specifically says cosine. So there we go. So I know that's going to be my starting point. Amplitude. Okay, for me to get the amplitude, I need to know what my maximum is, and my maximum here is 1. I can read that off. My minimum down here is negative 5. Okay, so my amplitude, A, is going to be the maximum, 1, minus the minimum, negative 5 over 2. So that's going to be 3. So the amplitude here is 3. I can quickly go to my vertical displacement because I use the exact same two values there. D is going to be 1 plus negative 5 over 2. It's the average of the two. So 1 plus negative 5 is negative 4 divided by 2 is negative 2. And like I said to you before here, what I think you should do here is when you get that, just draw in that line, that negative 2 there. Make it bold so you can see it. That's the middle of my graph. My graph should now go 3 up from there and 3 down from there, and it does. Okay, now my period. Okay, now to get the period here, like I did in the previous question, I would turn determining the period into a counting problem. So from here to here, I'm going to count out the number of blocks I get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, actually, It's interesting. That's similar to the previous question. So my period was 12 blocks. Now I got to figure out how big a block is. So I go to my graph here, I go to 0, and now I'm going to count it out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 blocks is 4 pi. So my period is 4 pi. Now, my period is 4 pi, but really what I'm interested in is finding the b value. B will be 2 pi divided by the period 4 pi. Oh, so my b value is a half. And that makes perfect sense because when I see a b value of a half, I know that there's been a horizontal stretch by a factor of 2. It's got twice as big, and in this case I'm seeing that. Okay? Now, at this point here, I could even determine the domain and range. The domain is quite easy. The domain is going to be element of the reals. The range, now I've already identified the max and the min, so this is hardly a challenge here. So this is -5 up to 1 here. I needed to know those two to get the amplitude and the vertical displacement. So this is just a statement of what I've already read off the graph here. Now, it's the horizontal phase shift that requires a little bit of effort here. Okay? Again, I want cosine, the cosine graph with a positive stretch there, or sorry, leading coefficient, not stretch. Stretch is always positive. I got to figure out how far over 2 blocks is. So let's just take a quick look at the scale here. 3 blocks over gets me to pi. This means that each block is going to be pi over 3. And so now that starting point for cosine should have been right here on the y-axis. It should always start on the y-axis, but it doesn't. It's been moved over. It's been pulled over. It's been pulled 2 blocks or 2 pi over 3s to the right. Okay, so there's my phase shift. It's going to be 2 pi over 3s to the right. Now, how do I put all of this into an equation? Well, it looks like this. Y equals positive amplitude, positive 3, cosine of my b value here, sorry, my b value was a half. That is factored out from my phase shift, which will be x. Now, to get to the right pi over 3 will be 2 pi over 3. To the right, 2 pi over 3. I close the brackets to close off the function here, the cosine function, because I want my vertical displacement to happen outside the function, again, just to make sure that it's vertical. So this is the equation that this particular question is asking for.
Assuming the minimum possible phase shift, write the equations of the following cosine functions where a is greater than 0.
Okay, well for this first graph here, the way to jump into these things is to identify the max and the min here. So our max is here at 2, our min is -4. So now that allows me really quickly to figure out what a is. A is going to be the max minus the min over 2. So 2 minus -4 is going to be 6 over 2. The amplitude here is 3. Okay, my d value, my median is going to be 2 plus -4, a max plus min over 2. So 2 plus -4 is going to be -2 divided by 2 is -1. So the middle of this graph is at the line -1. Okay, now I'm going to count out the period. My period here is going to be 1, 2, 3, 4 blocks. Okay, so my period is 4 blocks. Now what I got to do is figure out what 4 blocks is. So I go to my origin, 1, 2, 3, 4. Turns out that's pi. So my period is pi. Okay, now b is going to be 2 pi over the period, pi. So my answer is b is equal to 2. So now with this, I can tell you that my equation, I got to fit this in right at the bottom here. My equation is going to be y equals, now they wanted a positive leading coefficient here. So 3 cosine of 2. I still don't know what my phase shift is yet. I'll get to that in just a second. Close bracket, -1. Now let's take a quick look here. My phase shift, okay, is going to be the smallest distance away from the y-axis that the cosine graph could be. Now, cosine starts at the peak, so it's this one right here. That's the minimum phase shift here. Now, I just got to figure out what a block is here. This one block to the left, well, here's pi. There's 1, 2, 3, 4. There's 4 here, so a block, okay, if you want to think of it like this over here, a block is pi over 4. So this graph has been moved 1 pi over 4 to the left. So here we go. pi over 4 to the left. So that equation of that first graph as a positive cosine graph will be 3 cosine of 2 times x plus pi over 4, close bracket, minus 1. All right, for graph number 2 here, I just gotta have to fit the material in here. First thing I want to look at is my maximum and my minimum. So my maximum, I can read off this graph here. My maximum is going to be, this is 4, 5, 6, my maximum is 7. My minimum is just 1. Okay? So I know right away that my amplitude, which is going to be 7 minus max minus min over 2, is going to be 3. Well, just like the previous question here, okay? My d value, my median, is going to be the max plus the min over 2, and that's going to be 4. So I know that my middle of the graph is going to be here at 4. Okay. Now my period, okay, the period, well, I'm going to go from, well, I'll go from peak to peak here. I'm going to just count it out. That's 1, 2, 3, 4, 5, 6, 7, 8 blocks. So my period is going to be 8 blocks. But I don't know how big a block is. Okay, so I got to count it out here. So 1, 2, 3, 4, 5, 6, 7, 8. Well, if this is 2 pi here at 4 blocks, this is going to be 4 pi at 8 blocks. So there's my period, 4 pi. So now I got to figure out what my b value is. My b value is going to be 2 pi divided by the period, 4 pi. And so the answer is a half. And actually that makes perfect sense. If you just even take a look at it, between 0 and 2 pi, that is basically half of a period. Okay, so now here's my equation thus far. I've got y equals positive 3, there's my amplitude, cosine of my b value I found out was 1/2. I don't know what my phase shift is quite yet, but I know it got moved up 4 here. Okay, my phase shift. Well, I know that cosine starts at its peak. This peak here is the closest to the y-axis, so that's going to give us the smallest phase shift here. I just got to figure out what a block is. I know it's 1 block to the right. The whole graph should have started here. It's been shifted over. So how big is a block here? Well, 1, 2, 3, 4. Okay, well, there's 4 blocks to 2 pi, which means a block. Okay, a block is going to be 2 pi divided by 4. So a block is going to be pi over 2. So this graph has been moved pi over 2 to the right. So in my equation, it's going to look like this, minus pi over 2. So y equals 3 cosine of 1/2 times x minus pi over 2, close bracket, plus 4. All right, for graph number 3 here, notice that I'm only seeing a part of the graph, a part of the period here. But I know what fraction it is because I know I'm going from the bottom to the middle to the top here. That is half of a period. Those are only 2 motions here. This is half of the period. That's going to be really helpful here. But I'm going to have to figure out what my pieces are. So first of all, my max value here, this is 5, so 6, 7, 8, 9. My max is 9. My min down here was 1, 2, 3, negative 3. So now I can figure out my amplitude. That's going to be max minus the min over 2. Well, 9 minus 3 is 6, divided by 2 is 3. That has happened a lot. D is going to be the max plus the min. Oh, sorry. That's not true. Sorry, I did the arithmetic wrong. A is going to be the max minus the min over 2, minus the min. Ugh. The min here was negative 3, so this is going to be 12 over 2. This is going to be 6. D is going to be the max plus the min over 2. That is going to be 3. So the D value here would be a 3. Sorry about that. Didn't have enough negative signs in there. That's okay. Now here we go. To figure out what the period is, I got to count out the blocks here. Now, to go from minimum to maximum, that's going to be 1, 2, 3, 4, 5, 6, 7, 8 blocks. Now that's half the period, so therefore my period is going to be 16 blocks, twice that. Okay, now I got to figure out how much a block is. Well, there are 1, 2, 3, 4 blocks to get to pi. So that means each block is going to be pi over 4. That's only a fourth of pi. Now, so if that's true, that's 16 blocks. Each block there is pi over 4. My period here is going to be 4 pi. Okay, that makes it easier to work with because now I can figure out what the b value is. That's going to be 2 pi divided by the period, 4 pi, And the answer is a half. Now I hope you followed what I did there, because it's just a counting problem. I just counted the number of blocks in a half period, doubled it. And then I just looked at my scale here. There are 4 blocks to get to pi. That means each one of these things is a fourth or a quarter of pi. And then multiply that by 16 and you get 4 pi here. So now at this point, what I've got for my equation is y equals 6 cosine of 1/2. Okay, close bracket here, and then this is going to be plus 3. What I don't know is my phase shift. Okay, whoops, sorry, you can't see that. What I don't know is my phase shift here. But I know that cosine starts at the top, so this is a good starting point for cosine. And that is, I can just count this out here, that's 1, 2, 3, 4, 5. It's been shifted over 5 of those blocks to the right. Each block is pi over 4, so it's been shifted, and in the equation it'll look like this. It'll be shifted to the right 5 pi over 4s. That's what we're looking for.
Use the graph below to write the equation of the function as a sine function and as a cosine function where a is greater than 0.
Okay, now we're going to come up with these equations essentially simultaneously here. First of all, like we've done the previous ones, let's identify the maximum. In this case it's 4. And the minimum, I think, is clearly 0. Okay, so I can tell right now that my a value is going to be the max minus the min, so 4 minus 0 over 2, 2. My d value is going to be the max plus the min, 4 plus 0 is 4, divided by 2 is 2. So those two are identical to each other. Great. Now, the period here, I'm going to count out from, in this case here, bottom to bottom, and actually notice right away I can see it's 2 pi over 3. Like that was easy to see because it lined up really nicely with our grid there. Whoops. So now b is going to be 2 pi over the period, which was 2 pi over 3. And when you play with that a little bit, you'll find right away that the b value becomes 3. Now, that means over here, I'm looking for a sine and a cosine equation. My sine equation is going to be 2 sine of 3x. I don't know what the horizontal phase shift is yet, plus 2. Cosine is going to be 2 cosine of 3x. I don't know what the phase shift is yet, plus 2. So now I'm going to come over here. I identified that the d value was 2. So I'm going to draw that line in. And now, sine always starts at the middle. Sine always starts at the middle. Starts at the middle and goes up. So here's a good spot for sine, good spot for negative sine. Good spot for sine, good spot for negative sine. Oh, so here it was. This was the one for sine. Starts on the middle line. Now, okay, and someone's going to say, but it's not on the y-axis. I know it's not on the y-axis. How has it been moved away from the y-axis? Well, it's been moved 1 square to the right. Okay, well, now I got to take a quick look at these blocks here and figure out how big these blocks are. So there's 1, 2, 3, 4, 5, 6. Each block is pi divided by 6 because there's 6 of them to get out to pi. So each block is pi over 6. So this graph here has been moved 1 pi over 6 to the right for a sine graph. So here we go. For sine, that's been moved to the right, pi over 6. Now remember, cosine starts at the peak, so it could be this one right here or this one right here, and actually notice that they are the same distance away. So which one do you choose? Well, the truth is it doesn't matter. There's some symmetry there. Turns out you could put plus or minus pi over 3 here. Either one of those is totally acceptable. Do whichever one you wish.
Assume the minimum possible phase shift. Write the equation in the form of a sine function where a is less than 0 for each of the following.
Okay, so now the thing to notice in this case here is that we are expecting the a value here to be less than 0. So this is a negative sine graph that we're looking at. Negative sine graph starts at the middle and goes down as its first motion here. Now to build the equation here, I need to know a few things. First of all, let's look at the same stuff that we've been looking at for the last little while here. Grab the maximum value. The maximum value here is 5. Grab the minimum value here, and the minimum value is negative 3. From there, I can start to really build this thing. So I know that my a value is going to be the max minus the min over 2. So that's going to end up being 4. Okay, 5 minus negative 3 is 8, divided by 2 is 4. D is going to be the max plus the min over 2, okay? And so 5 plus negative 3 is going to be 2, divided by 2 is just 1. And now what I'm going to do is I'm going to go to 1, and I'm going to draw that middle line in there, that median line. Okay, that's going to help me in a little bit in this problem. Okay, great. Now I want to figure out what the period is. And so I'm just going to pick, again, 2 corresponding points on the graph. I'm going to pick these 2 right here. I'm just going to count it out, turn this into a counting problem. So in terms of my grid here, there's 1, 2, 3, 4, 5, 6, 7, 8 little squares that form a period. So my period is going to be 8 blocks. Okay? Whoops, sorry, 8 blocks. Now let's just look at the scale here and see what that means. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 4 pi. So my period here is 4 pi. And now I'm going to figure out what b is. Because b is going to be 2 pi divided by my period, which is 4 pi. And so I'm going to get that b is equal to 1/2. Great. Okay, so now I've got almost everything I need for this particular equation, except I need to know what my phase shift is. Now, for a negative sine graph, I start at the center and go down. Now look at that. That's right there on the y-axis. This one is perfect. There has been no stretch here, or sorry, no translation. So my equation is going to be y equals, okay, my a value was 4. Oh, sorry, and it'll be negative 4. My mistake here, I forgot this is negative sign. So y will equal negative 4. Sine of the b value was 1/2 x. There has been no translation. Okay, I would expect a sine graph to start on the y-axis, and this one does. And then it's been moved 1 up, so plus 1. So there's the equation of this function in the form that they're looking for. All right, so this is a similar question, same question, but just a different graph here. And again, notice that in this case, we're looking for a negative sine function here. So first thing we're going to grab here is the max. And just like in the previous question, the max is 5. When we look at our min here, our min value here is negative 1. Whoops, not negative 7, negative 1. Okay, negative 1. And so from there, I can immediately get my a value. That's going to be the max minus the min over 2. So 5 minus negative 1 is going to be 6, divided by 2 is 3. Our d value is going to be the max plus the min over 2. So 5 plus negative 1 is 4, divided by 2 is 2. And again, as I've done before, I'm going to draw this line straight across here at 2. This is the median. This will give me a better sense of how to find the phase shift and whatnot. Now I want to find the period. And again, I'm just going to count it out here. And actually, in this case right here, this graph is really nice for me because it starts, the minimum value here is right on the y-axis. So if I just look at where the next minimum is, I can see what the period is. I can just read it right off the graph here. My period here is 2 pi over 3. And so now I can use that to figure out what my b value is. Okay, so it's going to be the period 2 pi over, sorry, 2 pi divided by the period, 2 pi over 3. Well, now the 2 pi's are going to cancel, and when I divide by 1 over 3, I'm going to get 3 here. So my b value is just going to be 3. Perfect. So that's basically everything I need, except I need to now figure out what the phase shift is. But I have to know what a negative sine graph looks like in order to figure that out. So I got to think back to one of the earlier lessons here. And remember that a sine graph, again, starts at the middle. Sine graphs always start at the middle, but negative sine drops. So here's a starting point at the middle, and this one drops. This is the starting point for a negative sine right here. There's my first period. It should be starting on the y-axis. It's been pulled over. How far has it been pulled over? Well, to right there. And actually, I can read this right off the graph. It's been pulled pi over 6 to the left. Okay, so that has been my horizontal phase shift. It's been pi over 6 to the left. And so now I've got everything I need. Y equals negative. My amplitude was 3. Sine of my b value was 3. X, now pi over 6 to the left means plus pi over 6 inside the function here. And then it's been moved 2 up. And so there we go. Negative 3 sine of 3 times x plus pi over 6 plus 2. That's the function we're looking for.
Determine the equation of the sine function described below. Having an amplitude of 3, a maximum point at negative pi over 2, 5, and the nearest maximum to the right at 3 pi over 2, comma 5.
Okay, now this question is trying to get us to come up with the equation of the sine function by giving us the minimum amount of information, period. Okay, so first of all, we start with an amplitude of 3. Now, I know that that means whatever my equation is going to look like, I know that A is going to equal 3. Okay, that's easy because A is the amplitude. Now I got to try to figure out what the information they're giving me here. Now they tell me that I get a maximum at negative pi over 2. So negative pi over 2 is going to be right here, comma 5. 1, 2, 3, 4, 5. So right here is a maximum. And the next maximum after that is at 3 pi over 2. Okay, so it's going to be 1, 2, that's going to be right here, comma 5. Okay, now I know, based on what I know of these graphs here, that it's going to hit a minimum exactly halfway in between here. Now, I can figure out the period from this, first of all. I know that my period is going to be the distance from peak to peak. Okay, and they gave me the 2 peaks here. I'm going to count this out real quick. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I count that out along the scale just to see what it is, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My period is 2 pi. Now I could also have figured that out by simply taking the difference between the two x-coordinates. 3 pi over 2 and pi over 2, negative pi over 2. Okay, 3 pi over 2 minus negative pi over 2 is also going to be 2 pi. The difference between those would also be the period there. In any case, there's my period. Now that allows me to find my b value. 2 pi divided by the period, in this case, is just going to be 1. Okay, well, that's kind of nice. Now, that being the case, I know that if I go 12 units over, that's a full period here. So if I go 6 little blocks over, 1, 2, 3, 4, 5, 6, I know that this is the halfway point. Now, the halfway point between two maximums is going to be a minimum. Now, I got to think what that minimum is going to be. Okay, what that minimum is going to be. Well, the amplitude is 3, and so now I got to think about this. 3 down from the maximum. Okay, 1, 2, 3. This is going to be the median. That's the middle line. And then 3 down from that, 1, 2, 3. That's going to be my minimum. My minimum is going to be right here. So now I'm starting to really piece this together here. Now I can tell right now that my middle line is going to be at the line d is equal to 2. I know d is equal to 2 here because think of it like this. I know, for example, okay, I might come over here and say it like this. I know that the maximum is equal to d plus a. Now in this case, I knew that the maximum was 5, and I knew that my amplitude was 3. So I could bring that over. Here's another way I could figure that out. D is equal to 2. So now just take a look at this. I know my amplitude, I know the b value, I know my d value. I am 3/4 of the way there. What I need now is to figure out what my horizontal phase shift is. The way I do that is to think about the properties of my sine graph, or any of the sinusoidal graphs here. Remember that I can break these things up into quarters. Okay, that's the key to getting this question correct here. You can always break it up into quarters, and the quarters correspond to the different quadrants. Okay, so because there are 12 blocks or 12 little grid spaces here from peak to peak, divide that by 4 and you get thirds here. So this represents the first quadrant, second quadrant, third quadrant, fourth quadrant. I know for a sine function, because that's what this is supposed to be, okay, sorry, I shouldn't say it like that because that's a misleading here. I know this is a maximum. I know that in one quarter here, I'm going to go from max to a middle, and then it's going to go from middle to the min to the middle to the max. Now what I've drawn here is a cosine graph. Okay, what I'm interested in is the sine graph. Okay, now I can extend this back a little bit. I know it's going to go down there. It's going to go down there. It doesn't matter. Remember that a sine graph starts on the median line and moves up. So this could be a starting point for the sine graph. So could this. Oh, and notice the symmetry. That's pi to the left. This one's pi to the right. They're basically equally spaced out from the y-axis here, so either one of those is correct. So as a result, I can write this. y is equal to positive 3 sine of, what was my b value there? 1. Okay, so then this is going to be x. This could be plus or minus pi, and then the d value is 2. That would work fine here. I just got to choose which one of these I want to use, the positive or the negative. And that works out fine here. Or, now no, the question here doesn't actually specify that it has to be a positive sine function. This could have been a negative sine function. If it was a negative sine function, negative sine would start still in the middle, but its first motion is to go down, and so that's got to be the starting point right here. And notice that that is right on the y-axis. I don't need to horizontally translate it. And so the equation would be this then, negative 3 sine of x plus 2. And so either one of those would be an appropriate sine function for this graph.
Having a minimum at negative pi comma 2, and the nearest maximum to the right at the point 0, 6.
All right, now here's another question that tries to give us the minimum amount of information and encourage us to get the sine function here. Now I'm only told 2 points here. I'm told that I've got a minimum at negative pi comma 2, so my minimum here is at negative pi 2. And then I've got the nearest maximum to the right is at 0 comma 6. So 1, 2, 3, 4, 5, 6. So here's my maximum. Okay, now right there, that actually has provided me with actually a fair bit of information. I know that vertically, my maximum is 6, my minimum is 2. Well, that's huge, because I already know then that my a value is going to be 6 minus 2 over 2. 6 minus 2 is 4 over 2 is 2. And that the median line is going to be 6 plus 2 divided by 2. So 6 plus 2 is 8, divided by 2 is 4. So there's my median. And I can help myself out by drawing that horizontal line through at the median. And that's going to give me, that's going to help me out when I try to figure out what the phase shift is. Okay, good. Now, I need the period. Okay, now the period in this particular case is actually fairly easy to figure out, because to go from a minimum up to a maximum, remember that's going to go from, there's going to be two motions here, minimum to the middle, middle to the top. That's half the period. So from this point to this point here is half the period. Well, that was pi. That means that the full period must be 2 pi. And if that's the case, I know that I can go to I can get my b value by simply doing 2 pi divided by the period, which is 2 pi, and that's just 1. Okay, good. Now additionally, I know, okay, from negative pi to 0, I've got, how many blocks here? 1, 2, 3, 4, 5, 6. I've got 6 blocks. So that means in 3 blocks, or halfway there, I'm going to go from the bottom to the middle, and then from the middle to the top is going to take me another 3 blocks. Now the rest of my period here, again, the next motion here is going to go from the top to the middle. That's going to be 3 blocks again, because remember, each quadrant takes the same amount of time horizontally, same amount of space horizontally. So 3 blocks here translate to 3 blocks there, and then to go from the middle to the bottom, which will now be along this line here, another 3 blocks, and it'll take me down to there. Now, I am looking for a sine function. Sine starts at the middle, but sine goes up. Its first motion is to go from the middle to the maximum here. So this is the starting point for a sine function. And notice that this is negative pi, and already the way I've broken this up here, it should be clear to everybody here that this is negative pi over 2. I'm halfway. So a regular sine function should start on the y-axis. This one doesn't. It's been moved pi over 2 to the left. So I can write y equals positive 2 sine of, now it's going to be 1. The b value is 1. And this is moved pi over 2 to the left here. So this will be plus pi over 2. And then the d value, or the median there, is 4. So that's one way I could do it. But this could also be a negative sine function, and I know that a negative sine function starts at the middle and drops down. Its first motion is to go from the middle to the bottom. So this has got to be a positive sine function, a negative sine function. And again, based on the symmetry of the problem here, I know that this has got to be at positive pi over 2. So now I can come over here and write this out. Y equals negative 2 sine of x. Now in this case, it's got to be pi over 2 to the right, so minus pi over 2, and then again plus 4. And so those are the two sine functions being described by this particular question.